there's microprocessors practically anywhere, and most of them are hidden. Most of the people don't even know. And
Gideon Intrater, thank you so much for joining me on 20-Minute Leaders.
thank you. Thanks. It's good to be here.
So we're going to talk about metal today, right?
Bare metal, yeah.
Bare metal. Gideon, as a young entrepreneur going through Stanford here in Palo Alto, we see all the sexy things on the news and all these new and shiny devices and really, really cool things. But sometimes I think we forget to look back and really the core of what's happening and the core of technology, which you've been dealing with for quite some time now as,
Right.
in VP engineering positions, CTO positions. Let's talk about metal, but first, Giddy, tell me a little bit about where you come from.
Okay, so I've been a CPU architect pretty much my whole career. I've started way back in Israel and was heading the computer architecture team at National Semiconductor. Moved to the US with National, worked for a good number of years for another CPU company called MIPS Technologies. And until this morning, I was working at a semiconductor company called Adesto, which today was acquired by a different semiconductor company
Mazal
called
tov.
Dialog Semiconductor. Thank you very much. Yeah, we're all happy about it.
You're saying it so casually. Really,
Yeah,
Mazal tov.
yeah, thank you.
How many acquisitions of this now have you been a part of?
Oh, a good number of acquisitions. There's a lot of stuff that's happening in the semiconductor business. Now, it's not as visible as the software business or the apps business, but a lot of things are happening. I was at MIPS and it was acquired. I was consulting a number of startups that were, a bunch of them were acquired, and now this company that I'm in was, the deal was closed this morning.
Unbelievable. Gideon, why is this not in the news? I mean, this is obviously in the news. You just have to look a little bit deeper than, another autonomous vehicle company being acquired. But why is bare metal not in the headlines?
Well, first, you just don't read the correct, sources of media, right?
That's 100% true.
It's not as sexy as a software. It takes us much longer to get to an exit in this business. This business requires significantly higher investments. So two people in their garage cannot really get a company to an exit within a couple of years. That doesn't happen. Adesto, which is the company that I was part of, has been around for 15 years before it was acquired, about 8, 9 years before it went public.
Wow.
So it takes much longer. And the problem is we're building semiconductor devices. You call it bare metal, but what we're doing is designing semiconductor chips that are pretty much the baseline for pretty much all the software that's been used in the world. And we have to do a lot of things to make this happen, and it just takes time and money.
Okay, so let's dumb it down for me because I know nothing about this. What is the semiconductor business? What are these technologies? What are you building on a day-by-day basis?
So it depends. Different companies are building different things. Everybody knows about Intel, which is building, the CPUs that are driving the PCs. And now Apple is going to be building their own CPU that's going to drive the new Mac machines. So these are the things that are typically much more in the news. Then there's another tier of companies that are building products that go into cell phones. So a lot of people know about Qualcomm and other such providers. But then you go deeper, and for example, the business that we're part of, which is the industrial IoT. These devices are done by a whole bunch of smaller companies, and most of them you just don't have a clue that these devices are sitting within your printer or your food processor.
So we're
Or
literally talking about the chips, the chips that are
yeah.
in. almost everything that we see in our day-to-day right now.
Exactly. And many of them include CPUs inside. So a lot of them at the end of the day are running software. So there's a lot of design that goes into these systems, first building the chip, then building the software around it. So even the software people that are building the software that goes into that are not in the news. Nobody knows about them. But that's what actually is driving your car, and that's what driving pretty much every one of these devices that you're buying at Amazon.
Right. No, that's just incredible. And take me back a few years because you've been in this space for quite some time. And I grew up into a world that IoT, Internet of Things devices are prevalent, and almost everything I touch has a brain of its own. But I think when you started in this industry, it wasn't like this, right?
No, 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 no. I've been in this business about 30 years, and even at that time, computers were relatively scarce. There was typically a car had one processor that was controlling the engine, and that was it. Today, a car will have, tens and tens of microprocessors that are doing everything from rolling the windows down all the way to showing you the way. Even a cell phone has a number of microprocessors inside dealing with different functionalities. So there's microprocessors practically anywhere, and most of them are hidden. Most of the people don't even know. And this, what the Internet of Things is doing today is what used to be called in the past embedded systems, which were, systems where the software was deep inside. Nobody knew that about this software. It was just done by whoever built this system, but there was no way to update or upgrade it. Now with the Internet of Things, pretty much all these pieces are capable of being upgraded and updated over time, which makes it beautiful. It allows you to add features later in time. Tesla is made a whole business of upgrading your car pretty much after you actually bought it, which is something that was unheard of in the car industry before.
Incredible. So what is there to come? Because it seems that now everything is already connected and everything is pretty much communicating with itself. So what are the big milestones that we can foresee in the next few decades?
The big thing that's happening right now is actually taking AI and driving it all the way to the edge of the network. So your the camera in your door will actually be able to figure out whether it's you or somebody else. So, and a whole bunch of other applications where the knowledge, the know-how, the processing power, whether it's standard processing power or even AI, will all be at the end of the network, the edge of the network, without the need to go back to the servers and make decisions. And do that requires first for you to be connected, and second, there's latency. You don't want stuff to go up to the network, and you don't really want Amazon to actually take all the words that are being said within your living room and send them up to their server. You want to get the service, but you want it to be done locally without Amazon actually getting that information and storing it on their server. So a lot of this intelligence coming down right to the edge of the network will make a big change in the way these devices are operating.
Right. So, and it sounds to me that there are some hidden difficulties or hidden challenges that a software engineer like myself may not even realize, because I could be developing artificial intelligence models pretty easily, either using Auto ML by Google or just TensorFlow with Python or PyTorch. But it sounds like what you're saying is that the challenges of running these models on device, on the camera that's on the door, is not just the software. There's a lot of the processing power and the memory. Those are all challenges that we're still facing today.
Right. I can't afford to put a server farm in my house. So we have to figure out ways to make these algorithms more efficient, to make the hardware more efficient, so it would be able to run it. In many cases, you need to be running it with a limited amount of energy.
Right.
For example, the battery operated devices. So there's a lot of innovation that's going on right now into building devices that are smarter and capable of doing these smart things at the edge with the limitations of cost, power, and pretty much everything else that is what you expect at the end of the day to have in your, right next to your front door.
Definitely. So, and the things that you're building, are these the challenges that you're working on, making these things possible?
Yeah, we're working on AI at the edge. We're also working on security at the edge. So all these devices need to be secured, and
Right.
you really want to make sure that nobody manages to penetrate into your house, into your bank account through your, connected fan, right? So there's a lot of work that's being done in these areas as well.
Yeah, I
So
believe that it was somebody shared with me a paper from the Technion of a couple of people who managed to actually hack a ceiling fan and get some personal data about people through that.
right. Yeah.
Pretty fascinating. So, what excites you about this? I mean, this does sound exciting now that you're explaining what it allows, but at the end, you're not working on the camera of Ring, and you're not working on the ceiling fan. You're working on the technologies that then companies can use to
Right.
make their IoT, right?
Right, but what's happening is that the engineering uh, companies that are building the end product are trying to become leaner and leaner. And what happens is that the semiconductor vendors that are offering devices to these applications are providing significantly more software and more of the application within the device or within their offering. If you look today at the TV, for example, the chip that's actually controlling the TV comes from a vendor that provides not just the chip, but the operating system and
Okay.
a lot of the software. At the end of the day, the various OEMs, the main difference between their devices would be just the brand name on that pops up when you turn on the TV. Could easily be that 90% of the software is the same software that was built or provided by the semiconductor vendors. So semiconductor vendors are actually becoming much more of a vertically integrated suppliers of a lot of the software and a lot of the solution. We're providing the devices, we're providing the software, we're providing even boards that include all the pieces together. And then in many cases, OEMs in China and in Taiwan would just take these designs and pretty much take them to production.
Fascinating. And are there demographic shifts that you're seeing in the industry in terms of young people coming into it? Because I'm just thinking about my experience at Stanford. It's much sexier to go into software and just to use Python to write these machine learning code, and honestly most of the companies that are coming to hire on campus, that's what they're looking for. I don't remember a single company that came that had a standout and said, come work with us in the semiconductor industry. So
Right.
so what's happening with that?
Well, our industry is actually becoming older. You go and visit the offices, and you'll see people that are, slightly older than the people that you would see at typical Google, site.
Right.
Yeah, that's true. Although we're still getting a lot of young engineers, there's a shift of engineering from the US into other places where people value the semiconductor business more. So you'll see tons of startups in China.
Really?
You'll still see a bunch of startups coming up in Israel.
Oh yeah. By the way, why was Israel a hub, or is still a hub for this? Why is that?
Okay, that's a good story. Has to do with multiple different things, but one of them was Intel. Intel came to Israel in 1974 and started the design center, and then within a few years, engineers from Intel start moving to other companies. They thought they'll have better opportunities with American companies. So Motorola and National Semiconductor started design centers. But then in the late 80s, people started realizing that there's opportunities with startups, and money came in. A lot of people got to pretty much a glass ceiling in terms of as a subsidiary of a big American company, you couldn't get any further. So what happened was that, and money was relatively abundant, and so startups started, and I can tell you that in the early 2000s, Israel was probably more startups than practically any place in the world, maybe with the exception of Silicon Valley. Even now, I think there are more semiconductor startups in Israel than practically anywhere in the world. It's not the same numbers as there were in the early 2000s, but it's still a huge number.
So it's not that it was, more common just to go to the Technion and study the space. It was more so that the industry, by chance, came to Israel in 1974. People saw the opportunity, and it got everybody excited.
Yeah, and it was an exciting business. Think about it. At that time, the other businesses were mostly, build boxes for, L Tower, Elbit,
Yeah.
and so people, some of the top people in the industry, or actually the top students out of the Technion, went to work for Intel, National, and Motorola. At the time, I remember, I joined a little bit later than that, much later than that, about 15 years later. But at the time, for every job at National, we had about 100 people that were applying. And
Wow.
we definitely rejected people that were extremely good. Some of them are CEOs of companies that exited with millions and millions of dollars. And we told them, no, you're not fit for working for us. We could just pick whoever we wanted to work at the company.
Unbelievable. And is there a scarcity in good engineers in the semiconductor space?
I think there's always been scarcity in terms of good engineers. Good engineers are not growing on trees, and it's always been a challenge. And now there's definitely a bigger challenge due to the fact that there's a lot of people that are going to other businesses. And I don't think that the universities are generating enough engineers, neither in the US nor in Israel.
Right. No, and it's interesting to hear that it seems that there is a shift to Asia for a lot of these businesses as opportunities are rising. And I'm really curious to know about leadership in the semiconductor space. I talked to quite a few executives in leadership positions in the software space where I'm at. What is it like leading technology and leading teams in the semiconductor space from your experience? Is that different than in the software space, or are these sort of two similar animals?
I think they're pretty similar animals. There's obviously a little bit of a difference in terms of what you need to achieve.
Right. Also, the length of time that it takes to come to production, right? I mean, it takes years versus months.
There's also the risk. Software doesn't have to be perfect when it comes out of the factory. You can update it and upgrade it, and people invented this model of let my customer debug my code. You can't do that with semiconductor. With semiconductor, you take chip out, meaning you take it to production, and then if you have a bug, it will take you about 6 months to fix that bug. And the cost of fixing that bug could be hundreds of thousands or could be millions of dollars. So you can't really afford to have bugs. So the result is that the complexity of semiconductor devices is not as big as a complexity of a big software system where there's hundreds of people working on the same project. I think the biggest projects are Intel's microprocessors, probably 1 or 2,000 people working on a program. Most programs are much smaller with tens or hundreds of people. But so I think at the end of the day, software systems could be significantly more complex and more difficult to manage. However, they manage it to just operate, not be bug-free, where in semiconductor business, you have to figure out a way to make it bug-free. And the result was a lot of tools that were designed to help the engineers actually figure out ways to clean the bugs. Bugs are always inherent. You just need to figure out a way to get most or all of them out of the design before you roll it out.
It sounds pretty scary. You've got to experience quite a few rollouts and deployments of these chips. I mean, you deploy them and you're like, okay, we did our thing. I guess we're working on the next thing, and let's just hope that we don't wake up and see an article that says that there's a huge bug in one of our chips.
Yep. Well, you've seen what happened to Intel with some of these security bugs.
Yeah.
This is a disaster. The the number of chips that are deployed and the time that it was found, which was in some cases years after the chips were in the market. And now what do you do about it? So in many cases, you find some workarounds. Some of them are, reducing the performance of the device, and some of them are not completely foolproof, and you have to live with it.
I think I recall that there was an interesting case study from one of my business school classes of a time when a chip, it was found that it once every million calculations it had a miscalculation error, right? And it was a huge deal of how does the company, do they collect all the chips back? But you can't because they're already in all the computers, and it was fascinating.
Right. Yeah, it's a huge problem, and there's tons of money that's involved in it, both for the semiconductor vendor that's building the chip and for the OEM that sells it at the end of the day. And not an easy problem to deal with.
I think it takes a lot of courage to go and sell something to millions of people and hope that nobody finds anything wrong.
Hey, it's much easier than being, a structural engineer that's responsible for a bridge that falls, or a doctor that is actually doing surgery. So,
it's all relative.
So on the spectrum, it's not that bad.
I love it. Okay, Gideon, right before we leave, I want to thank you again for the time that you're giving this. And we didn't even talk about, I'm very curious. I mean, you're also part of J Ventures as a limited partner there. So you're also, active with early stage startups, and you're active also in helping do due diligence. And I love that you're balancing these two worlds, very technological, yet also on the investment side. But before we leave, I have to ask 3 words that you would use to describe yourself.
Okay, so I would say innovative problem solver. That's probably the easiest way to describe it.
Innovative problem solver. I love it. It's all about solving problems in the end, isn't it?
Yeah.
I love it. Gideon, thank you very much. Toda rabba. And congratulations on the acquisition from today morning.
Yeah.
Amazing. Amazing. All right. Take care. Bye-bye.
Bye-bye.